Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We're coming to this video with one more assumption, and that is the most important assumption that proves the OLS unbiasedness, and that is the zero conditional mean. So this video will be entirely on explaining the intuition behind the zero conditional mean. This is a condition that we have seen throughout the previous videos quite a lot, especially in the video where we talked about unbiasedness and the geometry behind OLS. Today we're going to look at it from the perspective of an assumption and why it's so important, and at the same time what happens when this zero conditional mean assumption is violated. The fact is, if this assumption fails, OLS could go completely wrong. So let's understand this thing. First of all, let's look into the mathematical interpretation. And for the simple regression, we're gonna write it as the expectation of the epsilon I, so the error term, conditional on our x. And then we just add I here because the x is for every individual that we have in our data set. This is equal to 1. So this is for the simple regression, the way that we will write it. And then in multiple regressions, it's going to be the error term conditional on x1i, x2i, and so on, again, equal to 0. Okay? What this says is once we condition on x, the average error is 0. No pattern, no trend, no leftover information. Because so far, remember, in our very basic model on the simple regression, we've always thought of the epsilon I as everything that we couldn't explain, that we couldn't include to explain our yi, which means that in this epsilon I, we could have shocks, we could have omitted variables, we could be including measurement error. There could be some luck involved in there as well, randomness. But what the zero conditional mean says is, after I have controlled for x, the unexplained part of y is just pure noise. So it means there will be no systematic patterns. And again, keep in mind, this is always when we talk between x and the error term. Okay. What happens when the zero conditional mean is violated? We'll have a problem that we will call endogeneity. And that could include a few things. So according to all of the things that the error term were including, that means that now all of these shocks or omitted variables, they are having now a say in our relationship. Although not directly, because we haven't included them as actual variables in the regression. So that means the problems that we say are omitted variable bias, we could have what we call simultaneity. We could have measurement error in X. And that could be, in case for some of you it's not very clear, basically what we're saying is that the noise in X spills into the error term. Now, every one of these things is going to create a case where we have the conditional expectation being different from 0, which then would mean, so the consequences would mean that the OLS is biased, the OLS is inconsistent, and we have to be worried that our statistical properties break. Okay? So in a sense, this assumption is literally the line between correlation and causation. The zero conditional mean, again, is the most important assumption in OLS. We will see in the next video how it comes together with the other assumption and how they together prove or like serve for us to prove the unbiasedness first statistical property of the OLS. But for now, keep in mind that whenever you have a case where you assume that the conditional expectation is not equal to 0, you have to be very wary of the consequences. Thank you for listening, and I'll see you in the next video.